Emily Allwater, and I'm an upcoming physicist at Catawba College, along with my fellow physicists, Alexis Robinson, as you will see right here, and Allison Backham, who is filming this wonderful video. And in lab this week, we took on a challenge to test the strength of nasal strips versus a regular nasal strip against a 50% extra strength nasal strip. Okay. To test these things, we had to do answer numerous questions about the lab. Number 1, does the nasal strip have numerous K constants per force, or is it only one single constant per spring?
Does the direction of motion affect the available force?
Is the force curve reproducible? Does it get weaker after 10 flexes?
1.
Is this one actually 50% stronger?
To test these things, we were given 2 normal strength breathe right strips and then 1 50% extra breathe right strip. And how we set up our experiment was we set up the track. It was a level track. There wasn't any increase or incline or decline. And we put the car on the track also. And then we had the motion detector up also so we could sense how far the car was pushed. And with each of these breathe right strips, we used the regular one first. We tested 10 different data points. We went all the way from 4 centimeters down to 1, and we decreased in quarter increments. And so what we did was we bent these to, say we started at 4. We bent this where there was 4 centimeters between each edge of the breathe right strip. And we secured the left side with our finger, and then we pushed the car up against the right side. And when we were ready to let it go, we moved our finger simply and let the breathe right strip expand and push the car down the track. From here, we use the vernier system to give us the acceleration for each way for the amount that the nasal strip pushed the car. And with the acceleration, we use Newton's second law, F equals ma, to find the force of the nasal strip on the car. And then once we had the force, we did the equation to find the spring constant for each of the nasal strips, the regular one, and then also the 50% extra strength.
You can see on this graph that you have in front of you on the screen, this is showing the force applied by the nasal strip on the cart at different distances that we measured, ranging from 1 centimeter to 4 centimeter.
This graph represents the force of the 50% stronger breathe right nasal strip on the cart.
This graph that you see here represents the difference of the forces between the 50% stronger nasal strip and the regular nasal strip. And as you can see, the 50% stronger nasal strip has higher forces than that of the regular nasal strip.
The graph that shows the analysis of the deterioration after 10 flicks of the nasal strip, you can see that the force stays constant almost throughout the whole 10 tries, while you can see towards the end it does tend to get lower. It shows a comparison in the K constants between the 50% nasal strip as well as the regular nasal strip, and you can see there's a consistent greater K constant in the 50% nasal strip than are in the regular.
As you can see, looking at our data, there are several different spring constants for different performance zones.
The nasal strip does not affect the force because of Newton's third law that says every action has an opposite reaction equal and opposite to it.
So did you know that the force curve is reproducible?
Oh my god, no way! After 10 flexes, there is no visible deterioration, but however, if more than 10 flexes, there may be some visible deterioration.
After going over our experiment, we found that the 50% nasal strip extra strength actually has a stronger force than the regular nasal strips. And compared to our other classmates, we got different results, but we found that this is actually a valid claim. Thanks for listening to our experiment. Have a great night, and we hope you
breathe right!